Welcome or welcome back at C squared. In this lesson we'll talk about the distance formula, which is the formula that allows you to find the distance between 2 points in a coordinate plane. You see the distance formula right here, and you notice it has a sum of two different squares, x2 minus x1 square plus y2 minus y1 square, and then take square root. You notice these are the coordinates of the point A, x1 and y1, coordinates of point 2, B, x2 and y2. You can prove this formula using the Pythagorean theorem, which says, if you remember, if we have a right triangle, I'm going to do a very similar triangle of the one in the picture, and this is A, this is B, and this is C. Remember, on the other side of the 90-degree angle is the hypotenuse. We have what? A square plus B square equal C square. Now let's see what A, B and C are in this triangle we have here. A is this leg, this segment, which has a corresponding segment right here on the x-axis is this segment, and the length of this segment is x2 minus x1. So this one obviously is going to be the same thing. So we're going to have here x2 minus x1 square plus, and now let's take a look to B. The B in this triangle is this segment, which has a corresponding segment obviously on the y-axis, a congruent corresponding segment, and that one is y2 minus y1. So obviously this one is going to be the same thing, y2 minus y1. So let's go back here, plus y2 minus y1 square. And now let's take a look to this C, which is the hypotenuse. What is the hypotenuse in this right triangle? Is this the distance between the 2 points, or the length of the segment. And now I can switch and rewrite d squared equal x2 minus x1 squared plus y2 minus y1 squared. The last thing I'm going to do, I'm going to take square root because I want to solve for d. And ladies and gentlemen, this is the formula we just start with. And you have here a short proof in case you need it. Now let's see a first example here. We have 2 points A and B. Find the distance between these 2 points A and B. The distance formula is, let's see if I remember, square root of x2 minus x1 square plus y2 minus y1 square, and don't forget the square root. So let's see now. I will suggest you to label the points like this: x1, y1, x2, y2. If you start with x2 and y2, that's okay, just be consistent. x1 goes with y1 and x2 goes with y2. So let's see what we get here. And we have x2 minus x1, 14 minus 2, don't forget the square, plus y2 minus y1, 7 minus 2 square. And let's move to the next step. How much is 14 minus 2? That will be 12, 12 square. So yes, use the order operation, plus 7 minus 2 is 5. 5 square. Let's move to the next step. 12 square, 144. 5 square, 25. 144 plus 25 is 169, so square root of 169, and square root of 169 is 13. The distance, or the length of segment AB, you can hear it away, is 13 units. Now, sometimes you're going to have a picture given to you, which allows you to use the distance formula, just identify the points, or use the Pythagorean theorem. I'm going to show you the Pythagorean theorem, but if you want to use the distance formula, identify the coordinates of the point, M, which is 2 and 6, and point N, which is 8 and 3. And you can use the distance formula, just label like in the previous example, x1, y1, x2, y2, and use it. But like I said, I want to show you a different way, because we have a picture. You can use Pythagorean theorem. So let's take a look here. We have this triangle. This leg is 3, this leg is 1, 2, 3, 4, 5, 6, 6. This is a right triangle, okay? So we're going to use a square plus b square equals c square, c being nothing else than this distance between the 2 points, or the length of the segment MN. So we're gonna have what we can call a6, so we're gonna have 6 square plus 3 square equals d square. So we're gonna have here 36 plus 9 equals 45, equals d square, I'm sorry, and this will be 45, so we're gonna have d squared equals 45. I want to find d, the length of segment of MN in this case. That will be square root of 45, which is the exact value, a good value. However, you may want to simplify. Remember, square root of 45 means square root of 9 times 5, and we can take square root of 9 and we get 3. 3 square root of 5 is the exact length of this segment. And we simplify the answer. If you need to evaluate, obviously you grab a calculator and do it with a calculator. In my next examples, we're going to have some real life application, and in this one, Maria uses the coordinate grid for modeling her neighborhood. And you notice her house is located at -4 and 2. The library is at 0 and 6. The park is at 2 and 4, and the school is at 8 and 8. And each unit grid is 0.25 miles. So a piece like this is 0.25 miles. That's what it says. Find the distance between Maria house and library. So let's take a look. This is Maria house right here, and the library is right here. Okay, since I have this choice, I'm going to use the Pythagorean theorem. I'm going to use this triangle. Now be careful here, because you notice this grid goes by 2, and remember each grid is 0.25, but let's do that at the end. But in other words, here we have 4 units, and from here to the library we have also 4 units. So I can use the Pythagorean theorem. A square plus b square equals c square, and I'm going to have 4 square plus 4 square equal c square, which is the distance between these two locations. I'm going to call it d sub 1, d1. So then we have the 1 square is going to be 16 plus 16, and that will be 32. And to find d1, I'll take square root of 32, which can be simplified, right? 16 times 2 will be one way, I mean the best way, and that will give us 4 square root of 2. But now this is units. Very important to understand, this is the distance. Now if we really want to find the distance in miles, we have to multiply this 4 square root of 2 by 0.25. And let's do that with a calculator. 4 times square root of 2 times 0.25, I end up with 1.41. I'm going to round it to the nearest hundredth of a mile. So very important, these two are good answer, but we're going to need the second one, this one, because they ask us the distance, and that should be miles. Okay, now let's move to the second part, part B, where we need to find if the park, which is right here, it's further away than the library. So I'm going to use pretty much the same approach. I'm going to erase this stuff here. We don't want to get confused. I'm going to change the color, and I'm going to need to find this distance. And can I use again Pythagorean Theorem? Of course I can. This is the triangle, and this one, let's take a look. We have 6 units here. Remember, it goes by 2, and here we have 2 units. So other than that, is the same type of approach. A squared plus b squared equals c squared, and we're gonna have here 6 squared plus 2 squared equals c squared. We're gonna have 36 here plus 4 equals, and let's rename that c d2, because it's the distance between these two locations, the house and the park. So now we can get d2 squared is 40, so d2 will be, if you set square root of 40, that's excellent. Of course, that is 4 times 10, and that will be 2 square root of 10. But this one, again, like the previous part, means units, which is a good answer, but we want to find the distance. So d2 will be 2 square root of 10 times the same 0.25, how much 1 unit is. So again, it's about taking the calculator now and put this in the calculator, and we have 2 times square root of 10 times 0.25. Let me erase that 0.5, because it's in fact is 0.25 here. I end up with 1.58 miles. So obviously, looking here, find if the park is further away than the library. Yeah, it is. I can even find by how much, by just subtracting these two values. 1.58 minus 1.41. Now let's go to part C, where we have Maria can go to school either way, by going to the library or going to the park. Which way is shorter? So she can go this way. Okay, so we have this d1, we need to find this distance. I'm going to go with d3. I'm going to use the same approach, this triangle, and this one is 1, 2, 3, 4, 4 boxes, 4 units, but remember this, it goes by 2, so this is 8 and this is 2. So again, one more time, a squared plus b squared equals c squared. Now in this case we have 8 squared plus 2 squared equal d3, d sub 3 squared. So we have here 64 plus 4 equals d3 squared. So d3 squared will be square root of 68, which is 4 times 17, and that means it is 2 square root of 17 units. But again, if I want to find the distance, I have to multiply by 0.25, and let's see how much that is. I end up with 2.06. I'm gonna put it right here. Okay, so we know D1 is 1.41, D3 it is 2.06. So if we do this way, I'm gonna say the red way, we're gonna have to add these two guys. And I end up with 3.47 miles. So the red way is 3.47 miles. One way for Maria to go to school, but she can use a different way. She can use this blue way, I'm gonna call it, go to park and go to school. And if you remember, this is D2, which is 1.58 miles. I'm only gonna need to find this length. Okay, again, Pythagorean theorem, since we use all this problem, and this one we have 1, 2, 3, but remember 3 times 2 in this case, right? Because we have 2 units. At 6, and here we have 2 units times 2, that will be 4. So I will call this one D4. The same formula, a squared plus b squared equal c squared. So this is the 1, 2, 3, 4 times when I use the same formula. Different numbers, we have 6 squared here plus 4 squared equals d sub 4 squared. That will be 36 plus 16 equals d sub 4 squared. And d sub 4 squared, that will be 36 plus 16, that will be 52. And if we take square root to get d sub 4 square root of 52, that will be 2 square root of, oh, let me show you why. That is going to be 4 times 13, which is going to be 2 square root of 13 units. Well, now let's find in miles. And that will be 2 square root of 13 times 0.25. And I end up with 1.8 miles. And I'm sorry, this is d sub 4, not d sub 3. Okay, so this is 1.8 miles. So now we need to find how long is the blue path. Okay, so what do we have to do here? Just add these two numbers. 1.8 and 1.58. 3.38. So if you notice, very close, this distance is this path. Okay, but again, if Maria wants to go fast to school, she better use the blue path. And the last problem in this lesson about the distance formula is this one. John is flying his drone and use the coordinate below for modeling this flight, and you need to find the total distance the drone flew if one grid represent 5 feet. So we need to find how long OA is, how long AB is, and how long BC is, because this is the path of the drone. I can start with AB, that is easy, 1, 2, 3, 4, 5. I'm gonna say 5 units, and I'm gonna use this last part at the end, very similar to what we did the other problem. But now we need to find how long OA is, and again, since I have this picture, it makes sense to use Pythagorean Theorem. You can use the distance formula also to check my work if you want. Okay, so here if we take a look, we have 1, 2, 3, 4, 5, 6, 7 units. 1, 2, 3, 4 units. So again, we're gonna have a square plus b square equals c square, and we're gonna have 4 square plus 7 square equals that length of the segment OA. I'm gonna call it D1 square. So we're gonna have here 16 plus 49 equals D1 square. So D1 square will be 16 plus 49, which is 65. So D1 will be square root of 65. It cannot be simplified. We can evaluate, and we can do that at the end if you want. But let's take a look to the last part of this problem. We need to find the length of the segment BC. This is a way to do it. Draw this triangle, and again this will be 7, but let's count again. 1, 2, 3, 4, 5, 6, 7 is similar with the other side, and this is 3. Okay, so we're gonna have the same approach. A square plus b square equals c square. The only difference will be the numbers. So we're gonna have now 3 square plus 7 square equals, I'm gonna call that c, now I'll rename it as D2. So we have here 9 plus 49 equals D2 square. So D2 square will be 9 plus 49. Let me rewrite this 9 a little bit better. And that will be 58. So D2, this up to will be square root of 58. Again, I don't think we can simplify to, yeah, so let's leave it like that. So now, what is the distance, the total distance? I'm gonna call it D. It's gonna be square root of 65 plus 5 plus square root of 58. And we can do this math here, but be careful, this is gonna be units. Okay, so I'm gonna put in the calculator now. And I end up with 20.68. I will round it to the nearest 100. 20.68 is the distance the drone is flying, but this is units. And if you want the distance in miles, multiply this number by what? By 5. And end up with 103 miles, 0.39 rounded to the nearest 100. And let me write the units here to be sure. Okay, for this part. If you enjoyed this lesson, don't forget to click the like button and come back and see square for more help. Thank you.